Let f be the function given by f of x is equal to e to the power of minus 2x squared. Find the first four non-zero terms and the general term of the power series for f of x about x equals 0. Okay? There are two methods. The first one is writing the Taylor or Maclaurin expansion and then finding all the derivatives and then plug in the value until you reach what? The four non-zero terms. Or we can use the expansion, the common expansion from the table. Okay, this is an exponential function, right? Yes. This is an exponential function. We know that the expansion of e raised to x is equal to what? 1 plus x plus x squared over 2 or 2 factorial? Okay, plus x cubed over 3 factorial and so on. So what will be the general term? X raised to what? X raised to n over n factorial, right? Okay, but we don't have e to the power of x. We have e to the power of minus 2x squared. The exponent is different. Look at this exponent. And this exponent is what? X. So what do we do? We replace what? X with minus 2 x squared minus 2 minus 2 x squared. So what happens if we replace it with minus 2x squared? Okay, so this is e to the power of minus 2x squared equals 1 remains the same 1 plus مكان x minus 2x squared. We will plug in minus 2x squared plus minus 2x squared over 2 factorial plus minus 2x squared cubed all cubed over 3 factorial plus, let's continue. مكان x here minus 2x squared to the power of n over n factorial. Right? Let's simplify. The 1 remains the same. Plus and minus 2x squared. What do we do here? Minus 2 squared. Minus 2 squared is 4, right? So plus 4 x squared to the power of 4 over 2 factorial. Right? And then minus 2 to the power of 3 minus 8 x to the power of 2 times 3 6 over 3 factorial. We have more? We said the first 4. The first 4 non-zero terms, right? These are the first non-zero. Okay, let's keep it for. We will use I think the 5th term, but in part C. We will generate it later. Plus, let's simplify this one. Minus 2 to the power of n, right? We can write it as minus 1 to the power of n times 2 to the power of n times 2 to the power of n and then x squared to the power of n all over n factorial. Right? So this is the first part. If we look at the answer key, there are 3 points. So there is 1 point for e to the power of u. We didn't use u, we kept it x. And e to the power of minus 2x squared, meaning replacing what? Replacing the u with minus 2x squared, and 1 point is given for the general term. Notice in the general term it's x to the power of 2n over n factorial, and we wrote x to the power of 2 to the power of n, which will be the same, x to the power of 2n. Okay? Clear?
Yes.
Okay. The second part is find the interval of convergence of the power series for f of x about x equals 0. So to find the interval of convergence, again, we said you have to apply what? Which test? The ratio test. However, we can say that the interval of convergence for e to the power of x is what? From? What is the interval of convergence for e raised to x? From negative infinity to? It's given in one of the tables in the PowerPoint of lesson 1015. So this is the second part. You can say for what? For e raised to x. The interval of convergence is from negative infinity to infinity. So for e to the power of minus 2x squared, the interval of convergence is from negative infinity to infinity. It will be the same. This is one method, or you can apply what? The ratio test. Again, the ratio test will give you the same interval from negative infinity to infinity. It says find the radius or the interval? Interval. Okay, so let's see what are they saying in the answer key. So they are saying that e to the power of u or e to the power of x converges for this interval. So the series for e to the power of minus 2x squared will converge also from negative infinity to positive infinity. So this is one method. Or you can what? Apply the ratio test. You will get what? 0, which is always less than. That means it converges absolutely from negative infinity to infinity. You can here say that this is what? Negative negative 2x squared. Okay? Or you can apply the ratio test. What about part C? Let G be the function by the given by the sum of the first 4 non-zero terms of the power series for f about x equals 0. Show that the difference between f minus g, which is the error, is less than 0.02 for what? For x is more than or equal to negative 0.6, less than or equal to 0.6. Okay, so It didn't say for a specific x value, it gave us an interval, right? But it makes no difference, it's the same. So for part C, if we apply the ratio test in the second part, okay, okay, so what do we do here? So the error is at most what? 8 sub 5, because we used how many terms?
The first 4.
Okay. We assume that, we didn't assume actually, this is, the error is the difference between the actual value minus the approximation, because it's an alternating series, so and it converges, we can use the alternating series error bound, and the A5 can be generated from here. So here, if I ask you what is the A sub 5, okay, what comes next? Here, to use it in part C, what comes next? 2, 4, 8, so it will be what?
16.
16
X to the power of
x to the power of 8 over 4 factorial. So this is the fifth term. So if you are approximating the value using 4 terms, the error will be at most A5. So this error is at most 16 x to the power of 8 all over 4 factorial. But what is x here? We need to find the greatest x value in the given interval. What is the greatest x value in the given interval? 0.6. 0.6. And this is equivalent to what? 0.011. Okay, this is less than the given one. What's the given error? 0.02. Is this less than 0.02?
Yes.
0.002. So this is the third part, part C. Let's look at the answer key, what they are mentioning here. There is 1 point for a correctly alternating series error bound of, which is the fifth term, right?
Yes.
This is the fifth term, 16 x to the power of 8 over 4 factorial. And 1 point is earned for correctly using x equals 0.6, okay? So this is the ratio test. I don't know why are they doing it? So terms are decreasing in absolute value. That means it converges. So this is what you need to do. Correct conclusion. The conclusion is that error is less than 0.02. And 1 point for using 0.6, and 1 point is for using the fifth term. All good?